Lowest common denominator, least common multiple, greatest common factor. People get these letters confused a lot. So this lesson is titled Alphabet Soup, making sense of all the letters. You'll want to make sure that you print the handout for your taking notes. It's provided below in the link or the description of the video. And you'll see here that I've thrown in a little bit of art history. This is Andy Warhol and just a few of his famous Campbell soup can paintings. The first letter in the alphabet soup that we're going to take a look at is the F, which stands for factors. Factors are quite simply numbers that you multiply with. 7 times 4 equals 28. The 7 and the 4 are the factors, and the product is 28. I find rather than trying to memorize the definition, if I can just kind of say to myself a few times, factor, factor, product, factor, factor, product, that kind of gets it into my head what a factor is. Interesting thing about factors is that they are finite. There's only a certain amount of factors for each number. We're going to go through and list the factors for 12 and 18. And I have a method that I like to use to make sure that I get all of the factors of a particular number. So I'm just going to kind of go through and demonstrate how I do this. Every number that we deal with can be divided by 1, so 1 is always going to be the first factor. 12 is an even number, so I know that 2 can go into it. And I also know that 3 can go into 12. So you'll notice I'm going in numerical order. As it turns out, it's 3 times 4. Now, I continue going in numerical order. 5, no. 6, yeah. 7, 8, 9, 10, 11, no. 12 does. Now you'll notice that might seem kind of tedious, but here's something that will maybe hopefully convince you that this is a good method. Take a look at those two outer numbers. 1 times 12, we'll do it again there. 1 times 12 is 12. And then the next two numbers moving towards the center are 2 and 6. 2 times 6. And then 3 times 4. When you hit that place in the list where the numbers are close together that multiply, that tells you that you're really close to being done. So let's take a look at it with 18. 1 can go into 18, so can 2, so can 3. 4 cannot, 5 cannot, 6 can, and it's 3 times 6. So there it is, 3 times 6, they're the closest ones in the list, so that tells me that I've made it about halfway through. Then I can start working the end of the list. 2 times what? 2 times 9. 1 times what? 1 times 18. And your list is done. So here's the factors of 12 and 18. The next thing we're going to do is we're going to look for the numbers that those two lists have in common. They have the 1s, the 2s, the 3s, and the 6s. The biggest one that they have in common is the 6. So for 12 and 18, the biggest or the greatest common, the one they have in common, factor is 6. The greatest common factor is 6. Big deal, right? Well, it is kind of a big deal because you use common factors for reducing fractions. A lot of times I'll see people reduce fractions in several steps. They'll start off, if they're both even numbers, they'll go, oh, it can be divided by 2. And then they might look at this and realize that they can go further by dividing by 3. And ultimately you get down to 2/3. Notice I'm using the 12 and the 18, which were the numbers that I used on the previous screen. However, if you know the greatest common factor, it allows you to reduce in one step. 12/18 can be divided by 6 over 6 and get that 2/3 in that one step. Now, isn't it interesting to notice that if you take the 2 and the 3 that we used up above for dividing, that those multiply together to make the common factor of 6. The next letter that we're going to look at in our alphabet soup is multiples. M for multiples. Multiples are best explained by example. The multiples of 5 are 5, 10, 15, 20, 25, 30, and so on. Dot, dot, dot means that we could go on this way forever. Multiples are infinite. Unlike the factors where there is a certain set of numbers that are factors, multiples can go on forever. For example, the multiples of 12, 24, 36, 48, 60, 72, 84, dot, dot, dot. We could do this on into infinity. The multiples of 8, and you'll notice these are the 8 times tables. And again, it could go on forever. This time, let's take a look at what these lists have in common. 24, 48, 72, and if we had extended our lists, we would have found even more. It's always good to look for patterns in math, so you'll notice if you look at the list for 12, every other one gets circled, and in the list for 8, every third multiple gets circled. This time we are looking for the least one, the smallest one that they have in common, which is 24. So, for 12 and 8, the least or smallest common multiple is 24. People get confused also about LCM and LCD. What's the difference? Least common multiple and lowest common denominator. For 12 and 8, the least common multiple is 24. Now I'm going to take that 12 and 8 and I'm going to make them into denominators for an addition problem. So I have 7 12s plus 1 8. And I know that I have to get a lowest common denominator. Well, turns out that that lowest common denominator is that least common multiple. The least common multiple gets used as the lowest common denominator. Basically, for your purposes, LCM, LCD are basically going to function as the same thing. One thing to point out is that when you're dealing with greatest common factor, that word greatest can kind of throw people off. Oddly enough, the greatest common factor of 12 and 8 is 6, which is actually a number that is smaller than 12 and 18. It's kind of an opposite thing. Also, the least common multiple of 12 and 8 is actually bigger than the 12 and the 8 itself. The least common multiple of 12 and 8 is 24, which is a number that is bigger than the 12 and the 8. And so one of the ways that I help my students remember this is SpongeBob. SpongeBob does this really annoying thing that he calls opposite day. You may have seen it on TV. And so with least common multiple and greatest common factor, we're going to kind of associate that with SpongeBob, that it's opposite day. And when we get into algebra and we're doing things with polynomials and monomials, that's really going to come in handy, as you'll see in the future. So that concludes our alphabet soup lesson. The artist that all the pictures that you saw was Andy Warhol. He was part of a art genre called pop art or popular art. It was during the 50s and the 60s and into the 70s as well. You may have heard this one quote by Andy Warhol: "In the future, everybody will be world famous for 15 minutes." He said that in 1968, long before the internet ever came along. So it's pretty interesting that he was able to figure out that lots of normal everyday people could end up being famous. And if you want to learn more about Andy Warhol, you can visit biography.com, and they have a nice short little video that can introduce you to why he was so important.